We have millions of sensory neurons delivering information to the central nervous system all the time. We have constant input from our environment, our surrounding area into the body. Millions of motor neurons are causing the body to respond in a variety of ways. We respond, we move in response to our environment. Sometimes you don't even think about it. Sensory and motor input travel by different tracks in the spinal cord. Remember, sensory input is afferent, coming in. Motor neurons carry output, which is efferent. Okay, you have ascending tracks and descending tracks. Ascending tracks are sensory. They bring information into the brain. Descending tracks are motor. Okay, they deliver information to the periphery, cause glands to contract, cause muscles to contract, to move the body, etc. So all tracks involve the spinal cord and the brain. They all go through the spinal cord to get to the brain. Okay. Naming a tract oftentimes involves its origin and its destination. So when you see the name of a certain tract, you know where it starts and you know where it ends. The spinocerebellar tract originates in the spinal cord and ends up in the cerebellum. The spinothalamic tract originates in the spinal cord and ends up in the thalamus nuclei in the middle of the brain. Okay, the thalamus is a relay center of the brain where a lot of information comes in, it gets transmitted into the cerebral cortex of the brain. Okay, so we got, oops, we did that. No, we didn't do that yet. Yeah, the corticospinal tract, where the origin is the cerebral cortex, and the destination is the spinal cord. You have the vestibulospinal tract, where it originates in the vestibular nuclei, and it ends up in the spinal cord. So a lot of times you can tell by tracks where they start and where they end up, just according to its name. Okay. You have three major sensory tracts. You have the posterior column. Okay. You have the spinothalamic tract. And you have the spinocerebellar tract. Okay. The spinothalamic tract starts in the spinal cord, ends in the thalamus. The spinocerebellar tract starts in the spinal cord, ends up in the cerebellum. Okay. These are called somatosensory tracts. All of these are afferent tracts. Okay. They're all sensory information coming into the central nervous system. Okay. This is a cross section through the spinal cord. We've seen this before. This is a dorsal root, our dorsal root ganglia. This is our ventral root. Okay. We have gray matter and white matter. Gray matter are the cell bodies. White matter is the axon of the neurons. Okay. Remember, there's three main tracts. This is your posterior columns. Your posterior columns are divided into the fasciculus gracilis and the fasciculus cuneatus. Those are the two divisions of the spinal columns. Okay? And that's where they're located in the spinal cord. Remember, this is anterior and this is posterior when we're looking at a cross section. You have the posterior spinocerebral tract, which is this yellow mass right here as it comes along the side. And you have the anterior spinocerebellar tract. Okay. You have the lateral spinothalamic tract, and you have the anterior spinothalamic tract. Those are the green areas right here and right here. Right? So the posterior column, we're divided into two groups. The fasciculus gracilis. The fasciculus gracilis transmits information from the cerebrum, okay, coming from areas inferior to the 6 thoracic vertebrae. So everything below the 6 thoracic vertebrae transmits information through the fasciculus gracilis into the cerebrum. The fasciculus cuneatus information comes from everything above the sixth thoracic vertebrae into the cerebrum. So that's the two divisions of the posterior columns. The dividing line is T6. Below it, it's the fasciculus gracilis. Above it is the fasciculus cuneatus that transmits the information. Remember, these are sensory. These are afferent columns. Transmit that information. The posterior columns. Okay, remember those posterior columns transmit proprioception, fine touch, pressure, and vibration sensations. Those sensations are transmitted through the posterior columns into the cerebrum. Okay. And this is your posterior column here, fasciculus gracilis and the fasciculus cuneatus. This is your posterior columns here. They run up through the spinal cord. They cross over to the contralateral side, then run up into the thalamus, and they get into the cerebral cortex. Okay, so that's how your posterior columns run. Okay. The spinothalamic tract runs from your spinal cord to the thalamus. That transmits information. It transmits pain, temperature, and crude sensations of touch and pressure. Those are sensations that are transmitted into the central nervous system by the spinothalamic tract. And this is you can see the spinothalamic tract. The anterior spinothalamic tract is right here. Comes up from here, crosses over, and this goes from the spinal cord up into the thalamus. Then from the thalamus, it goes into the cerebral cortex. Okay. This right here, this diagram, you'll see this throughout the text. Okay, this is homunculus. It's a copy of the human body, but the larger parts mean there's larger nerve innervations in those areas. Okay, so those are parts of the body that are sensitive and had a lot of nerve response in those areas. Okay? That's why it's distorted view. The larger the area, like the hand right here, you see how large it is? Those have a lot of sensory information coming into the central nervous system from the hand. Okay, and again, that's a homunculus is what that's termed. Okay, the laterothalamic tract again goes from the spinal cord to the thalamus. They have an anterior spinothalamic tract and a lateral spinothalamic tract. Okay, the spinocerebellar tract that takes information into the cerebellum. Okay, the other one's going into the cerebrum. This goes into the cerebellum. Transmits information like proprioception concerning your muscles, your tendons, and your joints. Proprioception is your body's ability to know where parts are. If you stick your hand out and close your eyes, your body still knows where your hand is. Okay, that's proprioception. Okay, and you do it through muscle tension, through the tendons and joints, how they move, and have the pressure that's on them to hold your body in certain positions. So your mind knows where your body parts are without looking at them. Okay, that's your proprioception. That's transmitted through the spinocerebellar tract into the cerebellum. Okay, and here's your spinocerebellar tract. Okay, feeds up into the cerebellum. Does not go to the thalamus like the other ones did. Okay, you have a posterior spinocerebellar tract and an anterior spinocerebellar tract, and both of them feed into the cerebellum. Okay, there's three chains of neurons involved in taking information from the periphery to the central nervous system. You get what's called first-order neurons. First-order neurons deliver sensation from the periphery to the central nervous system. Those are your first-order neurons. Neurons in your hands, in your legs, in your face. They deliver information into the central nervous system from the periphery, from the surrounding parts, from the environment around your body. That's a first-order neuron. It goes into the spinal cord. The second-order neuron desiccates to the contralateral side and ascends to the thalamus. Desiccate just means to cross over. right goes to left, left goes to right. That's what decussates means. So it decussates to the contralateral side, the opposite side, and it goes up to the thalamus. So your first order neurons go from the environment into the spinal column. Second order neurons run from the spinal column, they cross to the opposite side and go up to the thalamus. And then you have third order neurons. Third order neurons go from the thalamus to the cerebral cortex. That's where all the action occurs in your brain. That's where your thought process, your ability to think all comes in. Okay? So first order neuron, second order neuron, third order neuron. And that's what they look like right there. All right. So here's your first order neuron. Okay? You see the information coming in from the environment into the spinal cord. That's your first order neuron. Okay, see coming from the dorsal root ganglion into the dorsal root, up into the spinal cord. Okay, the second order neuron crosses over, desiccates to the contralateral side, and then goes up through the spinal cord to the thalamus in the brain. That's your second order neuron. Third order neuron goes from the thalamus into the cerebral cortex, where the actions occur in the brain. So first order neuron, second order neuron, third order neuron. So far, so good. All right, let's see what you learned so far. What's that structure pointing to? This mass right here. What part of the brain is that?
What do you think you're doing?
Cerebellum.
Yep, that's the cerebellum, right? All right. Next one, this tract right here. These are called your what?
Leo, can you please stop?
This would be your here, the spinal cerebellar pathway. That's a combination of the two groups. It's divided into two sections, right? To two tracks. So it's your spinal cerebellar pathway. It goes from the spinal column into the cerebellum. And the first path looks like it is to the anterior here. So that is your anterior. Well, I'm trying to say posterior. That's the back section. This is your posterior spinal cerebral tract. And the other one is what?
Anterior.
Anterior spinal cerebellar tract. Okay. Then you got in the center, you've got what?
Pons.
Area here. This is your medulla oblongata.
Oh.
Okay. That's the lower part of the brainstem. And from there, opposite the cerebellum is a swelling on the brain, which is a nuclei, which is the pons. We haven't gone over all those yet, but we will. Okay. So neurons and sensory tract are arranged in three anatomical principles, how they're divided. There's a sensory modality. They can be arranged by sensory mode. They can be arranged what's called the medial lateral rule or the somatotropic, what they affect. That's how we can organize these neurons. We'll go through those three different principles there. So sensory modality, fine-tuned sensations are carried in one sensory tract. So each sensation has a different tract. Okay? Temperature, pain, pressure. Each sensation carries a different tract. That's arranged by sensory modality. What type of sensation you're feeling. The medial lateral rule. Our sensory neurons enter the low level of the spinal cord or more medial within the spinal cord. In other words, if your sensory nerve is entering from your foot, okay, it's more towards the middle. If it enters from your upper part of your body, like your arm, it's more to the lateral side. The lower the sensory input coming in, the more medial it is in the spinal column. So sensory neurons that enter at a low level of the spinal cord are medial. Sensory neurons that enter at a higher level of the spinal cord are more lateral. We'll show you a picture of that in a second here too. And this by somatotropic arrangement, the ascending tracts are arranged or where they start from. Okay, so here's your sensory modality. Okay, sensory fibers arranged in the spinal cord. So each tract carries a different sensation. Excuse me, it's a different sensation up the spinal cord. Okay, so each one of these tracts will be a different sensation, and each sensation has their own tract. Okay, the medial lateral rule, the lower the input along the body, like the lower limb, the more medial, this is the medial portion here, that input's going to be. So your lower lip, your hip, your trunk, your upper limb, the higher you go up, the more you go to the lateral side. Okay. That's the second rule. The third rule is the somatotropic arrangement. Okay, that just says ascending fibers are arranged with individual tracts according to where they start in the body. So each one here, depending where they start, they have their own separate tract as it comes up. So your neurons can be arranged by the sensation they're feeling, by the medial lateral rule, or by where they start from to get the impulse to the spinal cord. Those are three-way nerves are grouped as transmitting that sensory information. Okay. Motor tracts. Motor tracts are the exact opposite. They're going out on the spinal cord. Sensory tracts are coming in, motor tracts are going out. All right, so the central nervous system transmits motor commands in response to all the sensory information. So all the input coming in your body, your brain votes on it and a response occurs. These are your descending tracts. These are your efferent tracts. Motor commands are delivered by two nervous systems, the somatic nervous system, which is your voluntary skeletal muscles. That's your somatic nervous system. Okay, directs the contact of skeletal muscles. And your autonomic nervous system. Those are your glands, your smooth muscles, your cardiac muscles, and all that. A lot of those are under involuntary control. Okay. So the motor contact, you have the two nervous systems, somatic, which is your voluntary skeletal muscles, and your autonomic, which is your involuntary smooth muscles, cardiac muscles, and glands. Okay. This is somatic nervous system. This is the motor control. This is the cerebral cortex. And it's coming down there, motor information, and it causes contraction of skeletal muscles. That's your somatic nervous system. Okay. It's voluntary control of your skeletal muscles. Okay. So stimulation of these lower motor neurons is always excitatory. It always causes the muscles to contract. Okay. There's two principal motor tracts from the brain. There's a corticospinal tract, and there's a subconscious tract. The corticospinal tract is the conscious control of your skeletal muscles. That consists of the cortical bulbar, the lateral corticospinal, and the anterior corticospinal tracts. These are the ones that have conscious control of your skeletal muscles. Subconscious tract, your autonomic nervous system. So conscious regulation of balance, muscle tone, eye, hand, upper limb position, where your hands normally sit. Okay? You don't think about your balance. When you're sitting there listening to my lecture, you can balance your head on your shoulders. That's part of the subconscious tract. It allows the muscles to contract to keep your head balanced. Okay? That's subconscious. You have to think about that. You have the vestibulospinal tract, the tectospinal tract, reticulospinal, and rubrospinal tracts. Okay. The corticospinal tract are three pairs of descending traits. Remember, they're descending. Their motor output. Okay. So this goes from your cortex to your spinal cord. You have the cortical bulbar tract. Okay. The lateral corticospinal tracts and the anterior corticospinal tracts. Okay, the cortical bulbar tract controls control of your eyes, your jaw, and your facial muscles. The lateral corticospinal tract controls conscious control of skeletal muscles, and the anterior corticospinal tract also has conscious control over skeletal muscles. Right? Again, here you see you're the same homunculus, the different areas of the body here. And you see the lateral corticospinal tract, which feeds information out, and that goes to skeletal muscles. And the anterior corticospinal tract, which also goes to skeletal muscles. Right? So everything comes out from the cerebral cortex. This is where the thought process occurs, and information is sent out. Travels down through different tracks into the anterior corticospinal tract and the lateral corticospinal tract to the voluntary control of skeletal muscle contractions. Subconscious motor tract have 4 tracks that are monitoring subconscious motor control. They have the vestibulospinal tract, the tectospinal tract, the reticulospinal tract, and the rubrospinal tract. Okay? Those are the 4 tracks of the subconscious motor control system. Okay? The vestibulospinal tract sends information from the inner ear to monitor the position of the head. Okay, the position of your inner ear, as we'll find out in chapter 18, I believe, is for balance of the body. Balances the head. It lets you know the position of the head. And allows you to balance it on the neck. Okay, the vestibular nuclei respond by altering tone, neck muscle contraction, and limbs for posture and for balance. Okay, that's your vestibulospinal tract. The reticulospinal tract sends information to cause eye movements and activates respiratory muscles. The rubrospinal tract sends information to the flexor and extensor muscles. Okay. The tectospinal tract. This one sends information to the head, the neck, upper limbs. This one responds to bright lights, sudden movements, and loud noises. Okay. If you're sitting here studying, one of your kids standing behind you and bangs on the door or drops a glass behind you, your head's going to turn, your eye's going to turn. You're going to hear the noise, you're going to see the noise, and you're going to spin towards that direction subconsciously. You don't have to think, what is someone drop behind me? Your head's going to spin automatically. And there's 2 areas that receive that. Okay. In the tectospinal tract, feeds into 2 areas in the brain called the superior colliculi and the inferior colliculi. But there are 2 bumps that are easily seen just in front of the cerebellum. Okay, just distal to the thalamus. The superior colliculi receives visual information. So the superior colliculi interprets that vision you see passing out the corner of your eye when you turn your head to see what that was. That's your superior colliculi. Your inferior colliculi receives auditory information. That's the one, if you hear a sound, someone draws something, you turn your head in that direction. Okay, that's the input that's received there. So the superior colliculi receives visual information. The inferior colliculi receives auditory information. And the tectospinal tract allows the body to respond to that information subconsciously, to the sight of what you see or to the sound of what you see, like those 2 control centers being activated. Okay. So these are motor tract causing subconscious motor controls. This is a rubrospinal tract. Okay. This is the reticulospinal tract, where they're located. This is the tectospinal tract. And this is your vestibulospinal tract. Okay. 4 different tracks for subconscious control. So far, so good. So we're looking at the brain. If you separate the cerebral cortex here and pull this back, this is a cerebral cortex here. This is a cerebellar cortex here. Okay. If you pull this back, you'll have this area exposed right here. These little bumps, the ones most anterior, are called the superior colliculus or colliculi. The one below that is the inferior colliculus. Again, the superior colliculus is responsible for sight, input of visual images. The inferior colliculus is responsible for hearing or auditory sounds. that are being input into the brain. Somatic motor control involved the cerebral cortex, where you think about it, the basal nuclei, where the information gets sent to, the cerebellum, which coordinates everything, the hypothalamus, helps determine the actions taken in different areas, the pons, the medulla oblongata, the brainstem, spinal cord, and the thalamus. All those are involved in muscle control when an impulse goes out from a command that your brain thinks of that it wants to get done. Okay. Anybody watch the movie Waterboy with Adam Sandler? You're real familiar with the medulla oblongata, right? Why alligators have expanded medulla oblongatas? Because they have so many teeth and no toothbrush to brush it with. All right, so here's we're going to go through all these sections. This is what we'll be covering. The basal nuclei. Okay, you can see where they're located in the brain. They modify voluntary and motor patterns at the subconscious level. Okay, the hypothalamus. Okay, hypothalamus controls stereotype motor patterns like eating, drinking, sexual activity, and modifies respiratory reflexes. It's your homeostasis for the brain. Okay, you have the pons and the superior part of the medulla oblongata, which controls your balance reflexes, more complex respiratory reflexes, as it comes out from the brain. Yeah, and you have the brain stem and then a spinal cord. Controls cranial and spinal reflexes. Okay. The inferior medulla oblongata, the part closer to the brainstem, controls basic respiratory reflexes. Okay. Everything goes through the medulla oblongata, through the brainstem. Okay, all your reflexes. Your cerebellum. Your cerebellum coordinates complex motor patterns. Okay, this is what my daughter calls your cool points. This is when you walk down the street and you don't trip. You know, when you're walking down the street and you trip, and all your friends look at you. That's when you lose your cool points, she says. So the cerebellum controls your cool points. It lets you walk without falling. It lets you perform coordinated movements without being real jerky at it. Okay, determines how cool you are. The thalamus and the mesencephalon, okay, control reflexes, response to visual and auditory stimuli. And your cerebral cortex, that's where all your planning occurs, all your thought. Everything you're thinking about occurs in the cerebral cortex. We're going to break all those down and go into detail on those. But that's an overview of how things work. So the somatic motor control, the cerebral cortex, the top part of your brain, initiates voluntary movement. That's where it starts. You have to think about, if it's voluntary movement, you've got to think about it. You have to control it. The first step in that is the cerebral cortex. From the cerebral cortex, it goes to the basal nuclei and the cerebellum. The cerebellum analyzes it, smooths it out, so the information sent to the muscles is not this jerky pattern. It's this smooth pattern that makes you look coordinated. Okay? So the basal nuclei and the cerebellum receive information from the cerebral cortex. Okay, these structures modify and coordinate movements so they're performed in a smooth manner. So you can maintain your cool points among your friends. Okay, so here's your cerebral cortex, motor associated areas. This is your decision in the frontal lobe. This is where you think. Information from the cerebral cortex gets sent to your basal nuclei and into the cerebellum. That's the first step. But you have to plan these motions. These aren't a knee-jerk reaction. You have to think about these before they can move. These are voluntary. Skeletal muscles have to be moved. Okay. Those are the basal nuclei and the cerebellum. So information goes from the basal nuclei and cerebellum are constantly monitoring position and muscle tone. So these two areas, they have proprioception. They know where your hands are. They know where your head is located. Yeah. They know what's leaning to the left, leaning to the right. So that once the impulse is sent, your head doesn't jerk one way than the other, or your arms don't go one way than the other, because it knows where they are. It's constantly monitoring the proprioception of your body. So the basal nuclei and the cerebellum know where all your body parts are, okay, in space. So when the information comes to them, they say, we're at this location. So now we move smoothly to another location. It doesn't jerk around to try to find the location. Then the information goes back to the cerebral cortex so it can make an informed decision on what movement it wants to make. So you constantly monitor position and muscle tone. Okay. So here we have that general principle of higher centers. Remember that picture we just showed you? These are your general properties of the higher centers of the brain. So what's this one here? This area right here,
The cerebral cortex.
the cerebral cortex. Okay. The next area is this box right there. This little egg-shaped thing.
Thalamus.
Okay. That's your thalamus. Thalamus and mesencephalon. Thalamus is a little egg-shaped structure there. And what's this part of the brain here? Sits below the cerebral cortex.
Cerebellum.
Cerebellum. Okay. And this is going to be, it's probably the,
Medulla oblongata.
yeah, the inferior medulla oblongata. That's the bottom part of it, right? Yeah, inferior medulla oblongata. Okay. And this would be your what? It runs all the way
Spinal
down.
cord,
Brainstem and
Brainstem.
spinal cord. Yeah,
brainstem and
perfect.
spinal cord.
Yep, perfect. And this area here, this is a swelling that sits directly opposite the cerebellum, which is called the what?
Pons.
Pons. With the pons and the superior part of the medulla oblongata. But this is the pons right here. Okay. And then this area is what? Right here. This is probably this square right here that sits just below the thalamus.
The hypothalamus.
That's right, the hypothalamus, below the thalamus. Perfect. There's only one left. You should all get
Basal nuclei.
These are the basal nuclei.
Hard.